Hey friends, welcome back. In this tutorial, we'll focus on Supabase Auth, which is a major feature of Supabase. We'll add authentication to a packet project, implement different auth methods, and expand our row-level security implementation. There are two core responsibilities of any auth system: authentication and authorization. So what are they? Authentication means checking that a user is who they say they are. It's like showing an ID card to prove you are who you say you are. When you log into an app, you typically enter a username and password. These are like your ID card. If they match what the system has on file, you're granted access. Authorization, on the other hand, means checking what resources a user is allowed to access. For example, in an app, you might be allowed to view your profile but not edit someone else's. Authorization ensures that users can only access and perform actions that they are permitted to, keeping systems secure and well organized. So let's look at the different auth methods. We have password-based authentication, which is one of the most common and traditional methods of verifying a user's identity in mobile applications. It checks whether you are who you claim to be by asking for a username, which could be a phone or an email, and a password. So a username typically identifies who you are, it's like your ID, while the password is your secret key that only you should know. It's what proves that you're indeed the person associated with that username. Passwordless authentication is a modern approach to user authentication that allows users to log in without needing to create or remember a password. So instead, users can authenticate using methods like email links, one-time codes, biometrics, or even social login. So Supabase Auth offers two of the passwordless methods that use the user's email address. We have the magic link and we have the OTP, one-time password. So a magic link is a passwordless authentication method where a user can log in by clicking on a special link that is sent to their email address. So this link acts as a temporary or a one-time password that gives them the access to their account without the need to enter a traditional password. So this is how magic links work. So the user enters their email address, into the app's login form. Instead of entering a password, the user clicks a button that says something like send magic link. Then the app receives an email to the user's provided email address. So this email contains a unique time-sensitive link. That's the magic link. Then the user opens their email, finds the message, and clicks the magic link. And this link automatically logs them into the app without the need for a password. Once the link is clicked, the app validates the request and logs the user in. So there are key features to look out for when using magic links. It's time sensitive. That means it's typically valid for a short period of time, either 5 to 15 minutes, and after this the link expires for security reasons. Also, the link can usually be clicked only once. After it's used, it becomes invalid, ensuring that even if someone gets hold of it later, it won't work. And lastly, since the link is sent to your email, the security of this method depends on the security of your email account as well. Great. So why would you use magic links? First, there's no need to remember or manage passwords, so users only need to access their email. Then also magic links reduce risks associated with weak passwords, reused passwords, and password breaches. Also, users can log in faster without dealing with password resets or complicated recovery processes. So you can see the main reason is the lack of using passwords. So you may consider this factor when deciding which auth method you want for your mobile app. The second passwordless method that we have mentioned is the one-time password, which is a password that is valid for only one login session. In short, it's used as a form of an additional layer of security as well, which we'll get to see. OTPs are mainly delivered through SMS, email, or through an app like Google Authenticator. So in our case, we'll deliver it via email. Other than password-based authentication and passwordless method, we also have social login. It's another auth method. So social login, also referred to auth login sometimes, allows users to sign in to an app using credentials from another service like Google, Facebook, app, or Apple or X. So instead of creating a new account with a new username and password, users can log in by authorizing access to their existing account on these social platforms. So this process is powered by Auth, which is a protocol that enables secure access to users' information from one service without sharing passwords. That's what Auth means. So how does social login work? First, on the login page of the app, you can select an option like sign in with Google or continue with Facebook. Then the app directs you to the social platform's login page, either Google or Facebook. If you are already logged into that platform, you won't need to enter your credentials. If not, you'll need to sign in. The social platform then asks for your permission to share certain information like the name or email address with the app you're trying to access. You review and approve, or you can also deny the requested permissions. So once you approve, the social platform will redirect you back to the app, confirming that you've been authenticated successfully. The app logs you in, often creating an account for you based on the data shared by the social platform like Google or Facebook. So the main key features of social login is that you don't need to create or remember a new password for the app. Your social account handles the authentication. Also, once you've signed in with a social platform, you can use that account to sign into multiple apps or websites without needing to log in again for each one. And lastly, you have control over what data the app receives from your social platforms. Most services let you review and limit the information you want to share. So some of the reasons why you'd use social login: it reduces that friction of creating a new account, remembering another password. You can log in with just a few clicks. So it's very convenient. Your password also is not shared with the app. This reduces the risk of password breaches, especially for smaller or less secure apps. Also, for developers, it simplifies user registration and login processes. So for users, it speeds up that onboarding process as they don't need to fill out lengthy forms. And you can also use the same social identity across multiple apps, making it just easier to manage your online presence. Let's look at another auth method, which will be anonymous sign-ins. So let's say you want users to try your app before creating an account. That's where anonymous sign-ins come in. Supabase can create a temporary anonymous user session so people can interact with your app and later upgrade to a full account. So it's great for guest modes. As you have seen, some apps like even YouTube or game apps, they have guest modes. That's where anonymous sign-ins come in. So back to application, we're going to work on the sign up and the sign in using Supabase Auth. Initially, we were just inserting a new user in the profiles table, but now we're going to use Supabase Auth. So I'll start off by sign up, where we enter the email and the password. So how the logic looks like is we're going to use supabase.auth and use the sign up method and pass in the email that the user has entered and the password. Once they sign up, whatever is returned, there is an object that will be returned in .user. So we need to check if the object is null, that means there has been a failure in creating this new user. But if there's an actual object with data, that means we have created a new user and then we can proceed into the email verification. But there's something to note also. If we go head back to our Supabase dashboard, initially we were storing information in the profiles table, but now where we're going to be storing it is in the auth schema in the users table. Now that we currently have no user. So what we want also is that once we create this new user, we want to be able to store this ID in our schema, because these tables over here in the auth schema are private. We cannot edit them. So we need, once the user is created in the auth schema, we want to be able to store that information in our public schema, mainly in the profile table. So we have two things. We have in our database, we have a function. We have two functions. So we have a function that says create profile for new, but the one I want us to focus on first is in the auth schema. So in the auth schema, we have a trigger that I defined. So what this trigger does is, what it does is that after this event, after insert event has occurred, after a record has been inserted in the users table in the auth schema, we want to call a specific function that I defined called the create profile for new user. So if we head over there into functions and proceed to our public schema, we have this function. So what does this function do? What this function does, it inserts into the profile table in the user ID column, it inserts the ID of the new record that has been inserted in the auth schema, in the users table in the auth schema. So that's what we want. So basically, without looking at the code, what we want is anytime that we add a new record in the auth schema in this users table, okay, there's a trigger that's generated that calls a specific database function and tells that what that database function does is that the moment a record is added in the users table in the auth schema, it picks that, passes that new record and creates a new record in the profiles table, inserting the ID of that specific record in, let me show you, the in the user ID, this one. Okay, the reason why we want that is that since we need certain information about the user still based on our application, but we can't edit it in the users table in the auth schema. So all we want is that when a user is added in the auth schema, let's have a trigger that creates a new record in our profiles table holding the user ID, or the ID of that new user in the auth schema. So that's what we have done. Now let's try and test that and see how that looks. So I'll head over to sign. We're already in sign up. And another thing to note is that by default, whenever you sign up, the email notification is enabled. So we'll get an email notification. But how I designed it in this specific project is, let's see, if we head over to authentication, we have emails. And in the email section, I defined the confirm sign up message to look something like this. Confirm you sign up. Use the following verification code, because we're using OTP as I had mentioned earlier, and then we are passing the token. The token that will be generated is one that will be set here, and then we just write, if you did not request this, please ignore this email. So that's how the email format looks like. So now let's proceed back to our code. Let's just try and sign up. We've successfully created an account and it has directed us to the email verification screen. So now in the email verification, or before we proceed to that, let's head over to the Supabase dashboard. Now if we refresh users, we should be able to see a record. There we have it. And thanks to the trigger and the database function that we designed, if we head over to our profiles table, a new record has been added automatically with the user ID of the holding the ID of the user created in the auth schema or in the users table. Great. So that is done. So the next thing is email verification. And as you can see in the authentication part, in the email section, we have a part where we have the email template that we want to send a token to the user. So I should be able to receive a specific token based on the sign up I have made. And there we have it. So we need to add this token. Let's add it. 133157. And once you enter the last code, it will direct you to the next screen. Let's look at the logic for verifying OTP. So when verifying OTP, all you have to do is you'll be passing the email address or the OTP. So what we say supabase.auth, then we use a verify OTP, passing the email and also the OTP that we have entered, and set the type of OTP that we're using, and it will go and process. If it returns a user object, that means it's not null. It will direct us to the next screen that we are in, else it will return the verification failed, try again later. Great. So now in our profile details, what this part will do is, we did this before. So what it will just do is table editor public profile. It just updates our existing record, the record that we have here. So the function is still the same. This part is already done. Just head over to and specify a color. So as previous in Supabase database, what this part was doing, it was updating information in the profile table. And then this one will add a new record based on this user and add a new car in the vehicles table. So from our profiles table, you can see now the name, the phone number, the email address, all these have been added. And then in our vehicle, you can see that we have added a specific vehicle based on a specific profile. Great. So now let's try and sign in our user, the credentials that we created with. We click on sign in. We are in. Let's have a look at the code. So what we've done is we are using Supabase.auth. We're using the method sign in with password. So we pass in the email and the password that the user has inserted, and it should return to us an object of type user. And if it's null, that means there's a probability that that account does not exist. So you'll be asked to sign up, else we'll proceed to the home screen. Great. So now that we have that, the next thing will be another thing to look at in Supabase Auth is signing out, which is also an important thing. So we have our logout here. So our logout will call the function sign out. And what sign out does, you will just proceed to call Supabase auth.auth again and call the method sign out. And then we're just resetting our provider, so that this is the only method you need to sign out the user. So if you proceed to do that, when you click on logout, we should be off, and we are informed that the user is not logged in. So that's correct because they are signed out. So another thing I want us to look out is this too, the sign in with Google and sign in with password. So I won't get into the nitty-gritties of that because already I have a full detailed user authentication tutorial on this too. I'll share in the description box below. But in terms of, other than the part for configuration, the logic or the shortcode that will be needed in the Dart code will look something like this. So I'll just look for sign in with Facebook. So we'll have sign in with Google. So you just proceed to call supabase.auth and then call the method sign in with ID token. And then you'll proceed to define the provider as Google and add in the ID token and the access token, which you'll get in the process of configuring. So please head over to the user authentication tutorial to have an understanding on how to configure Google for social media login. And also in the sign in with password with Facebook, same thing, but now we're using sign in with OAuth method. We define the provider, the redirect, and also we define the auth screen launch mode. So this is a logic that is needed after you have done the configuration setup. And when you set up the configuration, there's something that you need to add in the Supabase dashboard, which is, if we head over to authentication, we have auth providers over here. So you need to enable Google, and in the process of enabling Google, it will ask you to provide this information, and this information you'll only get it when you perform the configuration part. And also for Facebook, same thing, and you can get all this by following the step-by-step process in my user authentication tutorial. Great. Another thing we can look at is the Flutter Auth UI inside here. So we have the section for reset. This is the one that has Supabase email auth and sign up complete. This is how the widget looks like actually. It has different widgets like super email auth. Then we have super social is socials auth that displays now the sign in with Google and Facebook. So inside here, we're able to specify what we want to do when the user signs up, direct them to the email verification. And when the user signs in completely and it's successful, we inform them to navigate the user to the home screen. If they sign up successfully, we need to navigate to the email verification as we did in our own custom forms. So let's just try. That's the only part that I have updated, but you can have a look further. So these are just widgets that were defined to make it easier for us to inject authentication in our Flutter applications easily. So if we just try and sign in with the credentials that we created earlier and just say, let me enter the email. Then let me proceed to enter the wrong password. And let's just see. When you click on sign in, as you can see, it says invalid login credentials. Let's try again with the right credentials. And when I click on sign in, it directs us successfully to the home screen. So it actually works beautifully. So those are the main factors that we are looking at through the app based on Supabase authentication, where we're able to sign up, we're able to create triggers and functions within the auth schema. We're able to sign in a user, and we're able to sign out and interact also with Google and Facebook, which are social media logins. The reason why I haven't explained it in detail, that part in detail in this part, is because I have a detailed tutorial already. You can head over there and check on it. And once you understand the configuration for social media platforms, when you get those credentials, it's just a matter of inserting them, for example, in Supabase, in the Supabase dashboard, enabling it, and then interacting. That logic is usually the same. So you just run that logic and you'll be good to go. Great. Next, we'll focus on Supabase Realtime, another major feature. We'll use Supabase Realtime to listen to database changes in our Packet project. Supabase instance and expand our row level security as usual. Specifically, we're going to use it on our Packet car parking app to listen to live updates from our parking area table. So if someone adds a new parking area, deletes one, or updates anything, we'll see it reflected instantly on the Flutter UI. So Supabase Realtime is a feature that allows your app to get updates from the database as soon as they happen. So there's no need to manually refresh or pull. Under the hood, it uses Postgres logical replication and pushes changes via WebSockets. So there are three core real-time capabilities. So we have broadcast, which sends custom messages between clients, very good for creating chat applications. We have presence, where you know who is online. And then we have Postgres changes. This is the one we are focusing on that listens to insert, update, delete events. So when you enable real-time on a table, Supabase starts tracking changes using Postgres replication and pushes them to clients over WebSockets. So Flutter can subscribe to these changes. And it's very perfect for things like live chat or collaborative apps, and yes, parking area tracking in real time, as we shall see. In the Supabase dashboard, we'll set real time on the parking area table because we mentioned that we want to listen to the Postgres changes of this table and whether it's an update, a delete, or an insert. We're able to populate the changes on the front level. So in our parking area, all we have to do is click on it, select edit table, and then you need to check this part that says enable real time. Broadcast changes on this table to authorized subscribers, and that will happen in the front end side. So just all you have to do is enable this. And once you enable it, we'll head over to our code. And in our code, the lib folder, we were listing our parking areas in the home page or the home screen. So what we do, we create a simple channel, and this channel we define it. So we are saying that we're creating a channel called parking area, and we want to listen to the changes, all changes, meaning either it's insert, delete, or update. You can always specify this in whichever change that you want, action that you need. And then we've defined the schema and the table, and then we want to set a callback. But our callback will be as simple as running a set state. So when we run this command set state, it will refresh our widget, and the widget will be able to update or receive the latest list of parking areas. So let's see how that works. So currently we have 6 parking areas that are displayed on the home screen. So what we'll do is let's try and make a change on the parking area table, and we should be able to see a change in the you should be able to see a change in the front end or in the app automatically. So it should update in real time. So we head over to our parking area table. I will delete the parking area of ID 9. So when I click on delete one row, as you can see, we now have 5 parking areas on our home screen that has been updated automatically, and that's the power of real time. We'll focus on Supabase storage, which is also another major feature of Supabase. We'll use Supabase storage to upload and serve profile images from and to our Packet project and expand our row level security implementation. So let's jump right in. First, let's start with the basics of Supabase storage. Just like any cloud storage solution, Supabase allows us to store files like images, videos, and documents securely and efficiently. The key concept here is buckets. You can think of buckets like folders in a cloud storage system. In our app, we'll create a bucket specifically for storing user profile images. And for each image uploaded, we can define access control and security rules, ensuring that only the user who uploaded the image can access it. So with Supabase storage, we'll start by creating a bucket. And in our case, we have created a simple bucket called profiles that will hold all our profile images or the profile images of our users. So now we need to get into the logic. After creating the bucket, we head over to our code. And in our code, we'll start with upload. So we want the user to be able to upload a profile image. So obviously we'll need first an image picker, and in this case I've just set the image source to gallery, select any, and we check if the user hasn't selected, we return null. Else, if an image has been selected, we need to define it in a file, and then we get the extension of the file just to check if it's empty. If it's empty, we'll set the extension to JPG. Great. Now we want to define a unique file name for our images, and that's why this is there. We're using a UID to do that, and then we pass in our file extension from our image path. And then now we define our storage path, and our storage path, which will be stored in the profiles bucket. We want to give it also another folder called profile images in case we decide to store something else. So we'll have profile images, and then we pass in our file name. So this is the storage path. This is where it's going to be stored in our profiles bucket. And inside the profiles bucket, there'll be a folder called profile images and our image. So we proceed to call supabase.storage from profiles, the bucket that we defined, and then we upload our image using the storage path. Wait. So next thing is we want to check if this user is signed in. If the user is not signed in, we'll just mention the user is not logged in. The reason why we want to check this is the moment the user has uploaded a profile image in the Supabase storage, we want to save that image profile path to our profile table. So we call supabase.fromProfile, which is it's definitely in our public schema, and update a column that we are creating called profile image and store our storage path or the path toward the user's image. And we're checking whether the user ID is equals to whatever the user ID of the ID of the user that has signed in. So that's the idea of how we're going to do it in the app. So when you head over to profile, we have upload. We've called our upload profile here so that you can be able to select and upload an image. Let's check on the view the app itself. If we head over to profile, as you can see, we have this section where the user will be able to upload an image. So we'll just need to click on this and select an image. Currently on the table, I have set the profile image to null. So let's try and upload something like this. And we'll be able to view it, as you can see. So what we're able to display the image because of this file called download, this function called download profile. If we head over to download profile, what it does, it simply gets the user ID based on supabase.auth, and then if it's null, obviously it will say that the user is not logged in. Else we'll be able to proceed to the profile table and select the profile image column based on the user ID, which refers to whatever we have received from supabase.auth. Once we get it, if it's null, we'll just return null. We won't display anything, but if there's something, we'll pick that profile, the data or the path to the image, and then we'll create a single URL to be able to get this specific public. It's a public path for this storage path that we have stored in the table, and then we'll return it. And in the process of returning it is what we'll get over here in snapshot.data. If it's null, we'll set it as empty. If there's an image, that's when we'll display it using the network image. So it's as simple as that. So we have gone through the upload profile and delete profile. and download profile. So the one that is missing is the delete. So the upload, when you click on it again, let's just change the image to see the effect of, let's select the one with the green background. So wait for it to load. So it's going to add it in the bucket, and then it's going to this, because there's a change of state, proceeds to call the download profile and picks the correct profile image. And because we're creating a signed URL, it will provide for us like a public signed URL, because we're not using public URL. Sorry, I just clicked it again. So the last functionality that we need is delete. So when you click on delete, we should be able to, let's just check on the logic first before. So if you look at delete function, when deleting a profile, what we're doing are two things. First, obviously, we're checking if the user is signed in. We're going to delete the file from the Supabase storage that is in the profiles bucket. So we remove that specific image path that we have. And also we're going to remove the image reference from the database. That means we're going to head over to the profile table and just update the profile image to null, meaning that there's no image for this specific user ID in the bucket. So we're going to delete it on the bucket and also update the profile image of that specific user to null. So if we head over to our profile and just try and test that, if we click on delete and just wait it to load, it will tell us profile image deleted successfully, and as you can see, there's no image to display. Great. And here is our profiles bucket, and we have profile images, and you can see there are all these type of images that we have uploaded so far. So if we decide to delete, it will be deleted from this bucket, and also we're going to update the profiles table and set the profile image to null, as you can see. Another major feature is Supabase Edge functions. So we'll build a Supabase Edge function that returns the number of available parking slots for a specific parking area in our Parkit app, and obviously expand our RLS. We already have this on the parking area screen where we interact with the Supabase REST API endpoints, but now we want to replace using the API to using an edge function. So edge functions are serverless functions hosted by Supabase on the edge, closer to your users. Think of them like mini apps that you can write in JavaScript or TypeScript and deploy them with a simple command. They are called edge because they are deployed to Supabase's global CDN. So it's making them super fast with ultra low latency for users anywhere in the world. They run in a secure and isolated environment, are great for things such as user authentication and authorization. That means instead of handling authentication logic directly into your Flutter app, you can use an edge function to validate and authenticate users before they interact with your backend. So an example would be verifying JWT tokens before allowing access to a resource. Also, if your app relies on real-time updates, Edge functions can pre-process or filter data before sending it to your Flutter app. An example is when creating a chat app, you may need to filter your messages for spams or offensive content before displaying them. Also, you can offload heavy computations to Edge functions rather than running them on the user's device. So, for example, be formatting user uploaded data before storing it in Supabase. Also, Edge functions can act as webhook receivers for services like GitHub, Stripe, you naming, processing data before sending it to your app. So an example would be a Stripe payment webhook that verifies payments before unlocking premium features in your Flutter app. Just an example. And in our case, a custom API gateway, that's another use case that computes available parking slots in a parking area. That's what we're going to do. So you can use Edge functions as a custom API gateway. Now let's create our custom Edge function to get available slots for a given parking area. So let's implement Edge functions in our Parkit application. we in the parking area, when viewing a specific parking area, we have a place where we are able to display available slots in that specific parking area. We did that and it worked. We had the logic inside our Flutter application, but now we want to convert it and take that logic and implement it in an edge function and read it from there. So if we head over to our dashboard, how we do this is we head over to edge functions and then we define a new function, but we already have our function here that does whatever we want to do. So when I click on that, I select on code and here is our code. So let's have a look at it. So first thing, it's written in TypeScript. So if you're not familiar with TypeScript, this might be a little bit hard for you, but I'll try and explain every part. So first things first, we are importing type definitions here. Let's ignore that. Then we have import Supabase client. This is for now interacting with Supabase services. So we add that. And then the next thing now here, this is the entry point for the edge function or where the request will be made. So this is the request that will pass from the Flutter application and we're using Deno. So we'll proceed to create a try and catch. This is basic syntax code. So inside the try, we're going to pass a JSON body of the incoming HTTP request. So this is it. This is a request, and what we are expecting is a parking area ID to be passed. We need a key of type that's called parking area that will be passed in our JSON body from the request. So we expect it, and it will look something like this. Just an example. And then we pass in the ID of the parking area, maybe something like that. So this is what we expect in our JSON body. Then next, now we define our variable. We'll initialize our Supabase client. Here it is, and provide the specific URL credentials, which is a URL and the unknown key. And if you write it like this, already Supabase identifies this in this environment variables, so you don't need to define them in the secret section as they are. As long as you write it as this, it's already predefined. Then we're going to define the auth authorization of what the auth header. This will help us to what will it do? It will allow us to set the it acts on behalf of the logged in user, in short. So it's for authorization purposes. We'll get to see how we use that. Now let's create our request. So we have received the request. So what we're doing, if you look at this logic, it's quite similar to what we have done in that. So just calling Supabase client and then defining the schema where our table is, which is parking. And then we call our table and then we select. We want to select ID and the parking lot inner so that we can be able to use this information that's here to get available slots where available is true and the parking area is whatever has been passed in the JSON request JSON body. Simple as that. Then we're just doing a check. If there is an error, it throws an error, else it will return the data and the count on as you can see. So the count is already specified here. We're going to define it here, and that's what will be passed. Else if there's an error, it will be caught down below and provided we'll pass in a status of 500. So that's simple as is, because if you look this logic, we already have it in our Dart function, but we're just converting it into a TypeScript. We're wrapping it inside a try and catch and using Deno to serve our request and return our response. Then you click on deploy updates and it will deploy for you. Now let's proceed to our Flutter side and now call this specific function. So the function that we use is called get available slots. And in this get available slots, we had the logic where we were just calling the select, communicating directly with the database. Now what we're doing is we're using Supabase.functions and calling our function name. If you recall, we named our function just dynamic worker, and then in our body we are passing the parking area ID and the specific parking area ID that has been passed in our function. And then when we get the response, and with this return, that's enough to display our available parking slots for parking area. So back to our parking area, we didn't change anything on the UI level because we just changed the logic inside this specific function. So back to our app, if we just try to, as you can see, if we even select a different parking area, you'll see it will delay a little bit compared to when we were calling Supabase database directly from the app. As you can see, the result comes in 3 slots available for this specific suburban. Let's click on another one. As you can see, we have 1 slot available in the airport long-term parking. Great.